So number 3 is on the average rate of change of a function. So as I was saying, we kind of previewed this the other day when we talked about the slope between 2 points on a curve. And that's all it is. It's just the slope. Okay, so it says the average rate of a change of a function over the interval a to b is the slope between 2 endpoints on the interval. So in other words, the average rate of change is f of b minus f of a all over b minus a. Do you guys see that this is the same as y2 minus y1 over x2 minus x1? Exactly the same, because f of b is a y value. All right, so it says for the given functions or graphs of functions, determine the average rate of change between the given values. So it says for the function graph below, so this time we don't even have a function to plug into. And it says between x equals -2, so let's go over to -2. Let's assume each one's 1 unit. And between x equals 1, so here's that one as well. So the average rate of change is just going to be the slope joining those 2 points. Okay, so let's talk about what those points are. The first one is -2, 1, and the second one is 1, -1, right? So if we did f of -2 minus f of 1 all over -2 minus 1, f of -2 is the number 1. F of 1 is -1 all over -2 minus 1. So we get 1 minus a -1 on top, which is 2 over -3. So our answer is -2/3. Okay, and you can count it, right? We know that slope we can just count, rise over run. Is that what it is? We go down 1, 2 over 1, 2. Uh-oh, did I miss one? 3, I can't see. 1, 2, my spaces are so big. 1, 2, 3. Can you guys see it better on yours, or do the grid lines not show up? Yeah, mine are like kind of there. It's kind of hard to see. So over 3. All right, so the next one, so it says, well, what if we don't have the graph, but instead we have a function? So it's given to us. So we have f of x equals x squared minus 5, and we're on the interval -2 to 0. So we're finding it from -2 to 0. So it doesn't matter which point you do first, just like with slope. You could do like the first point minus the second point, that's fine, or the second point minus the first point. So let's go ahead and do f of 0 minus f of -2 all over 0 minus a -2. And this is called the average rate of change. So sometimes I write ARC equals average rate of change equals. Okay, so we have f of 0. Well, we need to find that. So maybe we'll find that off to the side. So f of 0 is going to be 0 squared minus 5. So don't we just get -5? So that's -5. And then f of -2 is -2 squared minus 5. Yeah, so this becomes 4 minus 5, which is -1, right? So we have -5 minus a -1 all over 0 minus a -2, which is going to be 0 plus 2, right? So 2. So we get -5 plus 1, which is -4 over 2. So our answer is -2. So that's the slope joining those 2 points. So when we were previewing this the other day, I almost got to the ones I wanted to get to, but I didn't quite. Okay, so the ones I wanted to get to are when we don't have numbers. So when we have like a 2, and then the other one's like 2 plus h, instead of between like 2 and 5, right? So what if we have between 2 and 2 plus h? Well, it's the same idea. It's f of 2 plus h minus f of 2 all over 2 plus h was the first x value, minus 2 was the second x value. So it looks a little weird, doesn't it? All right, so what we're doing is we're plugging this into the function. So how do I find f of 2 plus h? Do you guys remember how to do that from Algebra 2? Yeah, what do you think, Greta?
You just put 2 plus h in the x.
Yeah, we replaced the x part with 2 plus h, right? So it's going to look like that. So we're going to have 3 times 2 plus h squared. So let's write that in here. So we have 3 times 2 plus h squared. Do you guys see how the function was 3x squared? So we're replacing the x with our 2 plus h. So then we have minus whatever f of 2 is. So f of 2 is 3 times 2 squared, which is really just 12. So you can just write 12 if you want to. And then it's all over 2 plus h minus 2. What does the denominator become? 2 plus h minus 2? How do I simplify it? It's just an h, right? Okay, so we got to do a little manipulating here. So 2 plus h, quantity squared. I can't just bring the squared in, right? I can't be like, oh, 4 plus h squared. Right, that's the bad one, the freshman dream, as I called it. So we're going to do 2 plus h multiplied by itself. Do not feel bad if you have to write things down. I feel like when I'm tutoring people and like sitting next to people doing homework, they try to do everything in their head and then they make mistakes. Okay, I had to write this little step down, which seems silly. Like, I'm a math teacher. I should be able to handle this, right? I had to write that down until I was in AP Calculus. Like, I had to write it every single time. So that's fine. So if you want to write 2 plus h times 2 plus h and you FOIL it out, you're going to get 4. Your outer is 2h. Your inner is 2h. And your last is h squared. So we have 3 multiplied by 4 plus 4h plus h squared. And then we have minus 12 all over h. Then we continue to simplify. So we get 12 plus 12h plus 3h squared minus 12 all over h. So what's my next step in simplification? 12 minus 12? Yeah, it goes away, right? So now I have 12h plus 3h squared all divided by h. There's one last step in simplifying this. Okay? The h will go into every single thing. Do we see it? I used to draw that cheesy heart. like that. Do you guys remember? The h goes into both the 12h, so it goes both here and here. In other words, what we're kind of doing is we're factoring an h out, and then we're reducing. So our final answer is 12 plus 3h. Okay, so this thing that I just did is called the difference quotient. So it's taking basically like some kind of curve. So let's say we were at 3, and then we just go a smidge, very technical term, smidge. We're going a smidge over to the right to 3 plus h, where h is super, super tiny. And then we're finding the slope between those two. And what we do in calculus is we do this all the time, and then we take h, so it's even smaller, and then even smaller, and even smaller. So eventually h is 0. What would our final answer be if h was 0? Look at the 12 plus 3h. What would we get if h was 0? 12. That would be the slope at a single point. So at 3, that would be like, well, in 2 for the last example, that would be the slope of the tangent line. Okay, so we do this a lot in AP Calc. Tangent lines, basically anything that's like in nature or out in the real world that involves a rate of change, like when I say things like gallons per minute, dollars per day, those are all using calculus. Okay, so this is why we do this. I know it looks like really weird right now, but we're going to practice. All right, so it says show that the rate of change for f of x equals 2x minus 3 is always 2. Does anybody have any guesses on why this average rate of change would always be 2 for this function? Yeah, it's a slope. This is a line, right? Do you guys see it? Y equals mx plus b? And it's the slope. Isn't average rate of change the slope? Yeah, so your slope should be 2. So it doesn't matter what we're doing. So we're saying between 0 and 4, so we would have f of 4 minus f of 0 all over 4 minus 0. F of 4, if you want to find it off to the side, you can. F of 4 is 2 times 4 minus 3, which is 5. And f of 0 is negative 3. So we have 5 minus a negative 3 all over 4, which is 8 over 4, which becomes 2. So that was between the points at 0 and 4. Well, this next one is between the points at 3 and 50. So what are these points at 3 and 50? So sometimes I get kind of lazy and I don't write out like f of 4, f of 0. I just kind of write them as points. So what's the y value for x equals 3? 3? What's the y value for x equals 50? 97, good. Greta's like, it's too early for this. Did I get it right? So we're just finding the slope between those 2 points. So we're doing 97 minus 3 over 50 minus 3. So we get 94 over 47, which reduces out to 2. Okay, and you could do this for any pairs of points on this line, because the slope between any 2 points on a line is going to be 2 for this line, I guess. So what if we have a and a plus h? Well, we have f of a plus h minus f of a all divided by a plus h minus a. Okay, so think about how we're writing f of a plus h. So be an active note taker. Think about it. What does this mean, f of a plus h? Here's our function. We're replacing x with the entire a plus h. So it's going to look like 2 times a plus h minus 3. That's the first one. I'll put kind of brackets around it. That was this part. And then we have minus. So what about the next part? So maybe I'll put like blue ones around that one so you can see it. So f of a, what's that going to be? 2a minus 3, yep. And we're all dividing by a plus h minus a, which becomes h. Yeah, it will always be h on the bottom. So we end up getting 2a plus 2h minus 3 minus 2a plus 3. So we distributed that negative n all over h. And this is where the magic should happen. There should be lots of things that cancel, 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 and then you're magically going to be able to divide by h. Because remember I was telling you in AP Calc what we'll do is we'll take h going to 0 at the very end. What if I plugged in h equals 0 at the beginning? What happens if h is equal to 0 at the beginning of the problem? Yeah, it becomes undefined because we have this h on the bottom. Okay, so we can't put in h equals 0 till the very, very end. So we continue to simplify. So we're like, oh, 2a minus 2a, gone. Negative 3 plus 3, gone. We get 2h divided by h, which becomes 2. Isn't that what we thought it was going to be? Totally right. So if it's a linear function, you can find that difference quotient, which is really the average rate of change. You can find the average rate of change pretty quickly. All right, so this next one's not a linear function, so it's not a line. It's a parabola, right? So we have to go through these steps with it. So we're finding the average rate of change between 3 and 3 plus h. So we're going to do f of 3 plus h minus f of 3 all over 3 plus h minus 3. Okay, so I'm going to give you a second to try it, because this is a tricky thing for people in pre-calculus every single year. So just like when we have something like f of 7, we know when we have f of 7 that you should go into your function, right, if I gave you f of 7, and you would replace all of the x's with 7, right? You guys all get that concept. You were pros at that in Algebra 2. All right, so the f of 3 part's not hard. We know how to do this part right here, okay? It's the f of 3 plus h, which kind of throws people for a loop. It's kind of weird. So f of 3 plus h is the same idea. We're replacing all of our x's with 3 plus h. So it's going to look like 2 times 3 plus h squared minus 3 plus h. So do you guys see how the x's were here? X was being squared and then minus the x. So it's 2x squared minus x was our function. Okay, that is replacing the entire first circled item. So I'll kind of circle it so we can kind of keep it together. Then we're going to do minus whatever f of 3 is. Well, f of 3 is going to be 2 times 3 squared minus 3. You guys can always find that out off, or you can find that off to the side if you need to. Okay, the big thing to remember is that there's a big parenthesis there if you're subtracting out all of it. Okay? Does that make sense? So that was the second part of the problem. then it's all divided by 3 plus h minus 3. Well, 3 plus h minus 3 ends up just being h. So we're good there. So now we slowly simplify things. So this is where you can use scratch paper. You can kind of do this off to the side. It's fine. What I was saying is, I always had to write 3 plus h multiplied by 3 plus h off to the side. That's fine if you need to do that. When you do your FOIL, you're going to have first is 9, outer is 3h, inner is also 3h, last is h squared. So that simplifies into h squared plus 6h plus 9. Okay, but we have a multiplied by 2 right here, right? So we got to multiply it by 2. So we're going to have, let me write it out. So 2 times h squared plus 6h plus 9. And then we're going to have minus 3 plus h. Maybe I'll just write it out still with minus parentheses 3 plus h. And then minus, so what did that number over on the right become? The 2 times 3 squared minus 3. It was 15, right? And we continue to simplify. So we're like, oh, we got 2h squared plus 12h plus 18 minus 3 minus h plus, minus 15. And the way that you know that you did it correctly is that when you simplify the numerator, every single thing will have h. You're not going to have any just plain numbers up there. So do you guys see how this 18 minus 3 becomes 15? It cancels with a negative 15. Okay, did that happen on all of your papers? Okay, so that will always be the key, like the step where you know you did it right then. So we have 2h squared. It looks like 12h minus h. That's where the 11 comes into play. Oh, so I think maybe Greta and Eilish have this. So when you divide by h at the very end, you should have 2h plus 11.
I got 12.
Oh, so you didn't have the 11. Who? Lucy, was it you? The 11? Who had the 11? Oh, yeah, good. Hallie had 11. All right. Should we go back to ones with just numbers? Do we like the number ones better? Nobody likes the H's. All right, so this is saying find the average rate of change between 3 and 8. Woo, numbers, yay.
Oh wait, sorry. Why is it 11 again? Or like why? Or...
Because you have this 12h minus h, so I combined those.
Oh, so
It came from this
you
one.
combine before you divide.
Yeah, I combined two. I kind of did 2 steps in one, didn't I? All right, so let's find f of 3 and f of 8. So f of 3 is the square root of 3 plus 1, and then plus 7 on the end. So the square root of 3 plus 1 is the square root of 4, added to 7, which is 2 plus 7, which is 9. And 8 gives us 8 plus 1 plus 7. So we get the square root of 9, which is 3 plus 7. So we get 10. So we have 2 points. We have 3 comma 9, and we have 8 comma 10. All we're doing is the average rate of change is the slope. Okay, so we're finding the average rate of change. All of these are average rate of change. So we're doing 10 minus 9 over 8 minus 3. So we get 1 over 5. Done. Do we feel good with the number ones? Yay, numbers. All right, how about if they're weird numbers? Can we do weird numbers? Sure. So we have 5.2. So we're finding f of 5.2, and this is where I'll let you use your calculator. So we have 1 divided by 5.2. Now, if you really like fractions, it becomes 5, and 0.2 is 2/10 or 1/5, right? And you could write that as 26 over 5. So doing 1 over it would just become 5 over 26. Right? But some of you guys don't like fractions, and I recognize that. So go ahead and put it into your calculator. So do 1 over 5.2. And you get a decimal, right? So then do math 1. Do we all know the math 1 button on our calculator? Oh, it's your friend. All right, you do math. So hit the math button on the left-hand side. 1, and then hit enter, and it changes it into a fraction, which, as you can see, is the 5 over 26 that I had. All right, so how about f of 6.3? So go ahead and watch as I do the fraction method. So 6.3, what is that as a decimal or as a fraction? It's 6 3/10, right? How do we write 6 3/10 as an improper number? Remember, we do 6 times 10 plus 3, right? So 63 over 10. And 1 divided by 63 over 10 is the same as 1 times 10 over 63. So we get 10 over 63. So you can check on your calculator. Do you guys all get 10 over 63? You do. So it's nice to know this fraction stuff, but I'll let you use your calculator. My gift to you. All right, so we want to find the average rate of change. So we're going to do 10 over 63 minus 5 over 26 divided by 6.3 minus 5.2. Do you guys see why I'm letting you use your calculator on this one? So let's find the numerator first. So do 10 over 63 minus 5 over 26 on your calculator. Do you guys all know how to put that in? No? Okay. Just like you're saying it, 10 divided by 63. Whoops. Let me get it. Yeah, so I'm literally putting in 10 divided by 63, and then I'm doing minus 5 divided by 26. So you don't even need to put parentheses around them or anything because the calculator does the order of operations. So it's going to do the 10 over 63, and it's going to do the 5 over 26, and then it's going to subtract them. So we get that. You can see what it is as a fraction if you want, math 1. The lovely denominator of 1,638. And then we divide it by 6.3 minus 5.2. Now you guys can probably do that in your head. What do we get when we subtract those? 1.1. So you can do divide by 1.1, or you could do divide by, and if you didn't know what that was, you would have to put a parenthesis then. So you do parenthesis 6.3 minus 5.2. Unless you guys have that fancy font like I was talking about where it actually puts it in the denominator so you can see it. Okay, so we get negative 0.0305. So let's see if it changes to a fraction. So do math 1. So we get negative 25 over 819. How pretty, right? All right, so last little bit here. So it says, find the average rate of change between x and x plus h. So now we don't have any numbers. It's all variables. So we're finding it for x squared minus 3x plus 1. I did not give you much room here, so you might need another piece of paper. So we'll see. So it says, no, f of x plus h minus f of x all over h is often called the difference quotient and is used quite a bit in calculus. So we could just have a generic x instead of like a 2 plus h or a 3 plus h, okay? So it works out the same way. So let's do it. Are you ready? You guys look so nervous. You don't like the difference quotient, do you? All right, so we have f of x plus h minus f of x all over h. Okay, so that's what we're finding. Do you guys know why it's all over h? Isn't that really the same as x plus h minus x? You guys see how it worked out? It's the same idea that we've been doing. All right, so we get f of x plus h. So we're going to have x plus h squared minus 3 times x plus h plus 1. That is this part. It's like I'm torturing you. I'm hearing lots of groans. Then we do minus f of x. Well, f of x is just the x squared minus 3x plus 1. So the biggest mistake people will make is they'll forget parentheses around that because we're subtracting out that entire function, right? We need parentheses around there. So that was this part. Maybe you could use highlighters to help you. Some of you guys like to color coordinate your stuff. All right, so how about x plus h squared? Can we do that? X plus h squared. That's going to be x plus h times x plus h. So everybody try to write that down, see what you get when you do x plus h times x plus h. Okay, do we see that we get x squared plus 2 of those xh terms, right? Xh and hx, so you can call them both xh or hx, it doesn't matter, plus h squared. You guys with me? That was just this part. Then we have minus, we're going to do 3x minus 3h minus 3x minus 3h plus 1. I'm going to do a double-decker numerator. Can we handle the double-decker numerator? Do you know what I mean by that? So I'm going to do minus x squared. I'm going to line them up too. Plus 3x minus 1. And I'm going to put all over h. Do you guys see what I did there? Okay. So that shows us that the x squareds, the 3x's, and the 1's go away. So we have 2xh plus h squared minus 3h, all divided by h. So what do we think our final answer is? Is Greta going to be the only one that talks to me? You were the only one that talked to me in 7th period last year, too. Greta, go ahead.
H plus 2x minus 3.
Yeah, exactly. So we get the 2x, h, and a minus 3. So 2x plus h minus 3. That's our answer. And then in calculus, you'd go that step further. You'd take h as it went to 0. So what happens when h goes to 0? What's your final answer? 2x minus 3. Exactly. Good. All right, so application. So it says a construction worker drops a bolt while working on a high-rise building 320 meters above the ground. After t seconds, the bolt has fallen a distance of d meters, where d is equal to 320 minus 5t squared, between 0 and 8 seconds. What is the average rate of change? In other words, the average velocity of the bolt between 2 and 5 seconds. Okay, I don't like that they use 5t squared, but whatever. It's like physics. They didn't use exactly the right. It should be 4.9. So people that take physics would know that's 4.9. But we'll leave it as 5. They're making it easy on you. Okay, so what is the average rate of change? So we're trying to find between 2 and 5 seconds. So we're going to find d of 5 minus d of 2 all over 5 minus 2. So when you go on to physics and calculus and so on, you're going to need to talk about units. As Mr. Crawley says, units are the key to life. Have you guys heard Mr. Crawley ever say that? Yeah, units are the key to life. Distance is on the numerator. What units was distance in? Meters. Yeah, right here. Meters. What about the bottom, the 2 and 5 seconds? So we have meters on top and seconds on the bottom. So if we have meters on top and seconds on the bottom, what's meters per second? What is that? That's a velocity. That's like a speed, right? Like miles per hour, meters per second, right? So that's why it ends up being the average velocity. So we're going to find each of those. So we're going to find d of 5. So 320 minus 5 times 5 squared. So we get 195. Did you guys get 195? Check my work. All right, and then d of 2. So 320 minus 5 times 2 squared. All over 3. So 195 minus 300 is negative 105 divided by 3. So it's negative 35, and our units would be meters per second. Okay, so that was the average velocity. In other words, it was the average rate of change of the distance. A rate of change of distance is velocity. All right, and then the last one, so it says the enrollment rates of enrollment rates are of children in private schools in the U.S. from 1980 to 2017 can be approximated by this, where T represents the year. T equals 0 corresponds to 1980. Find the average rate of change of the model from 1980 to 2017, and then interpret your answer using correct units in the context of the problem. Okay, so what we're going to do is we're going to find 1980 has time 0. What is 2017? 37, right? So we're finding r of 37 minus r of 0 all over 37 minus 0. So find r of 37. Now the easiest way to do this, you can do this a couple different ways on your calculator. But what I do a lot of times is I cheat my way through. I let my calculator do all the work. Oops, sorry. So I'm going to put it in for y1. So go to y1. And I want you guys to put in this function, this negative 0.023, and you can use x. So you're going to do negative 0.023 x squared plus 1.49 x plus 37, or 39.7, sorry. Okay. Oops, I don't know why I did enter. So you can do this a couple different ways. You can go to your table, and you might be able to find 37. You could scroll down to 37 to find its number associated with it. Or if you guys have changed it so that you can select table set and you can go to ask, you can make whatever numbers you want on your table. So in your table, you could put in both 0 and you could put in 37 and find both those numbers. But here's an easier way. Yeah. So I did second table set. So if you were in my Algebra 2 class, you probably already have this set up. And then you go down to independent and you want to highlight ask so that you can put in whatever numbers you want. So you have a t-table on your calculator. So if you're ever trying to create a t-table for a certain graph, you can do that pretty easily. So then you go to table and you just put in whatever numbers you want. So you could do 1, -3, right? So your calculator also does f of 3, f of 5, f of whatever. Here's how you do it. So I know it's break time. I'll try to hurry. So we go to vars. Do you guys see vars? That stands for variables. We want the y variable, function, y1. So whatever you put in for y1, that's like our function. That's our f of x thing. So if I wanted to find f of 37, or r of 37 in this case, I do y1 of 37. It gives me that number. So if I want to find this numerator, I could just do that. I could do y1 of 37. So vars, y vars, function y1 of 37 minus vars, y vars, function y1 of 0. And that gets my number, and then divide by 37. So my answer is 0.639. So what do we think this means? So this is the rate of increase per year, right? So it's the rate that it would be increasing in this case, right? So you're increasing by that much every single year. So by 0.639 every single year. All right, so we'll stop there.